Hello everyone, today we will do a one short video on coordinate geometry where we'll start with introduction to coordinate geometry. We'll discuss the distance formula, section formula and midpoint formula and also solve a question on each of them. So let's start. Now let's start with an introduction to coordinate geometry. Now in earlier grades you must have come across number line. Yes, it's the line where you have 0, then you have positive numbers to the right side, negative numbers to the left side of 0, and this number line gives us the location or address of a point in one dimension or in one direction. But friends, many times we want to find the location of an object in two dimensions, right? It's more accurate. So there was a French mathematician called Rene Descartes. Okay, now he thought, why not keep two number lines which are perpendicular to each other on a plane surface. Now by plane surface I mean a two-dimensional paper, any two-dimensional surface, that's called a plane. So he thought, let's have two number lines which are placed perpendicular to each other, and he came up with something like this. Here you can see two number lines which are perpendicular. So this horizontal number line is known as the x-axis. See friends, it's labeled as x dash, and you have the vertical number line that's known as the y-axis. It's labeled as y dash. Now the two number lines intersect at a point and he called the point as origin. Okay, now just like any number line, these two number lines also have 0. So this will be my 0 at the origin, and you have positive numbers on the right side. Did you see that? There are negative numbers to the left. Similarly, on the y-axis, you have positive numbers up, you have negative numbers to the down of the 0. So it behaves like two normal number lines. So friends, this surface, this plane with the x and the y-axis is known as the xy plane, the coordinate plane, or it's also known as the Cartesian plane. You must have come across these terms. Why is it known as Cartesian? Because it's named after the mathematician Rene Descartes. Okay, so cart. That's why it's known as Cartesian. So this is the Cartesian plane. Now, friends, did you notice that this x-axis and y-axis has divided this entire paper, this entire plane into four different regions? See, this region over here, the second region, the third region and the fourth region. So these regions are also known as the quadrants. Now let's see the first region. This is the first quadrant. Here the x and the y-axis both have positive values. See, over here. So this is the first quadrant. Okay, here x and y both are positive. Now let's go in the anti-clockwise direction, friends. Okay, so the quadrants are named in the anti-clockwise direction. Now here, this is the second quadrant. Here if you see, the x-axis has negative values but the y-axis has positive values. What about the third quadrant? Can you tell me? Yes, the x and the y-axis both have negative values. And what about the fourth quadrant? Well, here the x-axis has positive values and the y-axis has negative values. So these are the four quadrants you need to be very familiar with. Now let's suppose we have a point P, say over here. Okay, now I want to know what is the location or the address of this point P on this xy plane. Now first friends, let's see what is the perpendicular distance of this point P from the x-axis. Can you find out the perpendicular distance? Okay, I'll just put some dotted lines here. Yes, what is the perpendicular distance? Yes, it's 3 units. How did I measure it? I measured it on the y-axis, right? So the perpendicular distance of point P from the x-axis is 3 units, and because I measured it along the y-axis, this distance is known as the y-coordinate. What is it known as? The y-coordinate. So here the y-coordinate is going to be 3 units. Keep that in mind, friends. Now let's see the perpendicular distance of point P from the y-axis. What is this distance? Yes, it's 2 units. And where have I measured it? Along the x-axis. So that's why the perpendicular distance of P from the y-axis is known as the x coordinate, because you measured it along the x-axis. How much is it coming out to be? 2. So I can say that the x coordinate of point P is 2 and the y coordinate is 3. And by knowing the x coordinate and y coordinate, you can uniquely identify any point on the plane. Okay, but every time saying that the x coordinate is 2 or the x coordinate is -5, the y coordinate is 10, instead of saying every time x coordinate, y coordinate, there is an easier way to represent the address of a point, and that is by putting a round bracket and writing both the numbers. Okay, the first number I will write is the x coordinate. That's right. So what is the x coordinate of point P? It is 2. We just found that out, right? And what is the next number that I have to write? Obviously, I'll write the y coordinate. So just remember, this is a more compact way of writing the address. First comes the x coordinate, then comes the y coordinate, and enclose it in round brackets. Now suppose I say there is a point Q whose coordinates are -3, -1. Shall we see where it is lying on this plane? Okay, -3 is what? It is the x coordinate, right? That is the distance of the point from the y-axis. So x coordinate is -3 over here. And what is the y coordinate? It is -1, right? That is the distance of the point from the x-axis. So that is -1. So here is my point, friends. See, point Q -3, -1. So just by knowing the coordinates of the point, I can find out where that point lies on the xy plane. That is the power of coordinate geometry. Now friends, one more important information is that the x coordinate is also known as abscissa. What is it known as? Abscissa. And the y coordinate is also known as ordinate. Yeah, the spelling is ordinate, right? Okay, so just remember these two terms also. X coordinate is abscissa, y coordinate is ordinate. So friends, with this introduction to coordinate geometry, we are now in a position to see what is the distance formula. So once again, here is my xy plane. This is the x-axis. This is the y-axis. Here is my origin. Now I have 2 points, P x1, y1, Q x2, y2. I have to find what is the distance between these 2 points. Now what do I mean by P x1, y1? The coordinates of P are x1, y1. What does that mean? That means point P is at a distance of x1 units from the y-axis and y1 units from the x-axis, right? So shall we mark all those things, friends? Let's quickly do that. This is the perpendicular distance from the x-axis. So what is it known as? Yes, it is known as y1. And this distance, did you see that? This is the distance of that point from the y-axis. So I'll call it as x1. Similarly, let's see point Q also. This whole distance, right? The perpendicular distance. This is the perpendicular distance of point Q from the y-axis, which is known as x2. And this whole thing, friends, see? This is the perpendicular distance from the x-axis, which is y2. Okay, now we have to find which distance. Let's mark that also. We have to find this distance PQ. Now friends, did you observe that these are all perpendicular lines? So I can draw a line which is perpendicular to this line. See? It's a 90 degree. This is a graph. Everything is perpendicular. Let me mark this point as say R. Since this is a right angle triangle, I can use the Pythagoras theorem. Do you remember what is the Pythagoras theorem? Yes, the hypotenuse square. Yes, it is equal to the base square plus the height square. Do you remember that? Okay, now what is the hypotenuse here? Yes, it's the side opposite 90 degrees. So PQ square is the base square, which is PR square, and the height is, yes, QR square. So if I somehow find what is the value of PR and QR, I will be able to find this distance PQ, right? Now let us see what is this PR. Now, this is my PR, and yes, did you see? This is x2 and this is x1, friends. So if I subtract x1 from x2, see, if I do x2 minus x1, won't I get this PR? Definitely. So what is this distance? It's x2 minus x1. I hope it's very clear to you. Similarly, what is this distance? Yes, it is y2 minus y1. See, because this whole thing is y2 and this is y1. So y2 minus y1 will give me my QR. So let me substitute these things. PR is x2 minus x1. Of course, it's squared. And QR is, yes, y2 minus y1 the whole square. That's it, friends. We are just almost reached the distance formula. Now here it's PQ square, but we don't want square. We want PQ itself. So what will I do? I will just take the positive square root. Now why am I taking the positive square root? Because distance cannot be negative. So that's why I'm taking the positive square root. See, this is my distance formula, friends. Very, very easy. Okay, so what is it? Root of x2 minus x1 the whole square plus y2 minus y1 the whole square. Now remember, friends, that you can also interchange. You can write this as x1 minus x2 the whole square also. It doesn't make a difference in this case because you are anyway going to square it. So even if you take x1 minus x2, you may get a negative answer, but it will get squared. So it doesn't matter whether you do x2 minus x1 or x1 minus x2. The result will be the same. So now let's do a simple question on distance formula to understand it better. So here is the question. The x coordinate of a point P is twice its y coordinate. If P is equidistant from Q and R, find the coordinates of P. Okay, friends, so go through the question 1 or 2 times, and before you start doing any calculations, very important is to draw the diagram. For any geometry question, it's very important because then only you will be able to get a better idea. So let's draw the diagram. So I have a point P, okay, and it is equidistant. Equidistant means it is at the same distance from 2 other points, right? Okay, let me mark my point Q. They have given the coordinates of Q, and there is another point R, okay. Now it is equidistance. That means this distance is the same. What is given to us? Okay, it is given that PQ is equal to not QR, it's PR, right? PQ is equal to PR, that is given to us, okay, and we have to find the coordinates. So what do we have to find? We have to find coordinates of P, that is, I have to find what is x and y. So x and y, let's take it as coordinates of P. I have to find that. So what are we waiting for? Let's apply the distance formula. So let me call this as x comma y. Let me find out PQ. So what is PQ? Yes, apply the formula. Okay, what is the distance formula? Let me write it here. It's x2 minus x1 the whole square plus y2 minus y1 the whole square. Okay, so x2. So this is my x1, this is my x2. Okay, so I'm going to write x minus 2 the whole square plus y2 minus y1. Okay, so I'll just write y minus of minus 5. Now friends, it doesn't matter whether you write minus 5 minus y or y minus of minus y. It really is going to be the same. So this is x minus 2 the whole square. Now y minus of minus is y plus. So these things you have to take care, friends. See, there is a minus and there is a minus. So it will become y plus 5 the whole square. Now for the time being, just leave it like this, okay? Just leave it like this. Now let's go to find PR. Okay, so PR also I'm going to apply the same formula. Okay, now again, this is my P, this is my R. So x2 minus x1. So x minus of minus 3. Again, take care of the double minus. Okay, and this will be y minus 6 the whole square. So this is nothing but, yes, x plus 3 the whole square plus y minus 6 the whole square. But we already know that PQ is equal to PR. So let's substitute over here. So this PQ is nothing but square root of x minus 2 the whole square plus y the whole square. Okay, which is equal to x plus 3 the whole square plus y minus 6 the whole square. Now there is a lot of problem if I keep this square root sign. So that's why we are going to square on both the sides, friends. Okay, then only I can think of doing something. So let me just square on both sides. So when I do that, the square root just vanishes, right? And now things are easy. So now I have to apply the identities. A minus b the whole square, do you remember? Yes. Let me apply all those identities here. Okay, this will become y square plus 25 plus 10y. Am I right? Okay, this will be x square plus 9 plus 6x plus y square plus 36 minus, yes, 12y. Now, the great thing is that x square gets cancelled, y square gets cancelled, and that's it. I can't cancel anything else. So let me just add 4 and 25. I'll get 29 minus 4x plus 10y, which is equal to 9 plus 36 is 45, right? Okay. Now, what I can do is I can see x and x here, y and y there. Let me just bring everything to one side. So what I'll do is I'll put 0 equal to 45 plus 6x minus 12y plus 4x minus 10y minus 29. Okay, friends. So 45 minus 29, I will get it as 16. 6 and this will become 10x. This will become minus 22y. And that's when I realized that I totally forgot one piece of data, which I'm sure you must have noticed. The x coordinate of the point P is twice the y coordinate. Yes, I totally forgot something you should not do. So the x coordinate is twice the y coordinate. So this data I'm now going to use over here. So wherever there is x, you're going to put 2y. Okay, so let's do that. So this is what we get. We'll get 20y minus 22y, right? So 16 plus 20y minus 22y will give me minus 2y, which means 2y equal to 16. So y is equal to 8. That's great. Now y we got as 8. Let me just put that value here. So when x is 2y and I put y equal to 8, what will I get as x? 16. That's right, friends. So x is 16 and y is equal to 8, but we don't have to leave the answer like that. We have to give the coordinates of P. So we have to give it in the proper order. So we can say that the coordinates of P are 16, 8. First the x coordinate and then the y coordinate. I hope you understood, friends, how to do this question. Now let's come to the section formula. So again, let's consider 2 points, A x1 y1, B x2 y2. Let's just join these 2 points with this line segment. Now on this line segment, we have a point P. Okay, there are of course infinite points. Let's take a point P which is dividing this line segment in some ratio. Now what do we mean by that? Let's suppose I'm taking the same line segment AB. Say suppose it is 14 centimeters. Okay, friends. Now I'm taking a point P over here such that it is dividing this line into 2 parts. See, maybe this is say 4 centimeters and this is 10 centimeters. Then how is it dividing this line segment? I can say it's dividing it in the ratio 4:10. I can further simplify it. I'll get it as 2:5. That's what they mean, friends. So this point P is dividing this line segment in some ratio. Let's call that ratio as M1:M2. Like here it was 2:5. Like that I'll take it as M1:M2. We have to find what are the coordinates of this point P. Okay, so let's call the coordinates as x, y. Then friends, using the concept of similarity of triangles, we have a proof by which we can get the coordinates of this point. Let's not go too much into that proof because it's a little bit lengthy, but we'll just mention what is the formula. So this is the section formula. The x coordinate is m1 x2 plus m2 x1 divided by m1 plus m2. Okay, and the y coordinate is m1 y2 plus m2 y1 divided by m1 plus m2. Now in the beginning you might find it very complicated, but really it's not if we understand how to remember it. Okay, so just remember for the x coordinate you will have only the x coordinates x1 and x2. You will not have y1 and y2. So that is one thing you can keep in mind. And wherever you have m1 you have to combine it with x2. Okay, and wherever you have m2 you combine it with x1. So see here, m1 then immediately x2 comes plus m2 x1, and denominator is always m1 plus m2. Now let's come to the y coordinate. In the y coordinate, again you will have only y2 and y1. Okay, there will be no x coordinate here, and again the same way. See, here it's m1 x2, here it's m1 y2, here it's m2 x1, here it's m2 y1, and again the denominator is m1 plus m2. So very easy to remember, friends. This is the section formula. Now let's do a question based on this formula to better understand it. So friends, here is the question. If the point C minus 1 comma 2 divides internally the line segment joining A 2 comma 5 and B in the ratio 3:4, we have to find the coordinates of B. So again, let's draw the diagram. Okay, so we have point C which divides the line segment AB. So my line segment is AB. Okay. Now the coordinates of A are already given, B it's not given, and this point C, okay, it divides this line segment in the ratio 3:4. Okay friends, we have to find the coordinates of B. So let me write it as x2 comma y2. Okay, so this is all the given data. So we can write given data. Let me write that quickly. Okay friends, so I have written the given data and what we have to find. So what are we waiting for? Let's apply the section formula. So x is equal to m1 x2 plus m2 x1 divided by m plus n. So what is my x? Yes, it's minus 1 and m1 is 3. 3 into x2 obviously we don't know, and m2 is 4 into 2. Yes, divided by 7. 3 plus 4 is 7. Let me bring the 7 to the other side. I'll get minus 7 is 3x2 plus 8. I can bring the 8 to the other side. So minus 7 minus 8 is 3x2, which means 3x2 is minus 15 and x2 is minus 5. See, so easily we got the answer. But we still have to find out y2. Let's do that. So what is the formula for y coordinate? Y equal to m1 y2 plus m2 y1 divided by m1 plus m2. So y is nothing but 2 and m1 is 3 into y2 is going to be, obviously we don't know, and m2 is 4 into y1 is 5 divided by 3 plus 4, which is 7. So we get 14 equal to 3y2 plus 20. Let's bring the 20 to the other side. So what is 3y2? Yes, it's minus 6, which means y2 is equal to minus 2. So that's the value of y2. So let's write down the coordinates of point B. The coordinates will be, yes, x2 which is minus 5 comma y2 which is minus 2. Friends, I hope you got the answer. Now let's come to the midpoint formula. It's actually a special case of the section formula. Let's see how. So again I have 2 points, A x1 y1, B x2 y2. Now again we have a point P. Okay. Now but this point P is going to be the midpoint of AB, friends. What is it going to be? The midpoint of AB. So can you guess in what ratio it will divide this line segment? Okay, it will divide in the same ratio, 1:1. So here M1 is to M2 will be 1:1. Say for example, it is dividing it in the ratio 6 centimeters, 6 centimeter. Then the ratio will be 6/6, which is 1/1. Right? That's why M1 is to M2 is 1:1. So let's see what will happen to the section formula. Our section formula is this, if you recall. Yes. So here M1 and M2 I will substitute as 1. So X will be 1 into X2, which is X2. Here also 1. It will be X1 divided by M1 plus M2 will be 1 plus 1, which is 2. Just see, friends, how your section formula has reduced. Now it has become so simple. X is nothing but x2 plus x1 by 2. Now shall we see what happens to the y coordinate? Yes, y is m1 by 2 plus m2 y1 divided by m1 plus m2. Okay, again m1 and m2 are 1, so it will be y2 plus y1 divided by 1 plus 1, which is 2. See, Midpoint formula is even easier than the section formula. You just have to add the y coordinates and divide by 2, add the x coordinate, divide by 2, and you get the coordinate of that midpoint. Very easy, friends. So let's quickly do a question based on this. Now the question says the coordinate of one end of a diameter of a circle are 4, minus 1, and the coordinates of center of the circle are given as 1, minus 3. We have to find the coordinates of the other end of the diameter. Okay, now let's draw the diagram and see what the situation is. So I have a circle. Let me draw a rough circle like this. Okay, this is the center. Now there is a diameter, obviously. So let me draw the diameter through the center. Okay, now one end of the diameter is given as 4, minus 1. And the center is also given as 1, minus 3. We have to find coordinate of the other end of the diameter. So friends, let me label these points. I'll call it as P, Q and R. Okay, now we have to find R. So I'll call it as x2, y2. Now the special case is that this is a diameter. So what are these two line segments? PQ and QR are the radii of the circle and they have to be equal, right? That means this Q here is the midpoint of this line segment PR, because Q is the center and PQ has to be equal to QR. So Q is the midpoint of the line segment PR. So let us write all the given data. It is given that PQ is equal to QR and the coordinates of P and Q are given. Let me write that down. X1 is 4, Y1 is minus 1. And x I'm going to write as 1, y is minus 3, and I have to find what is x2 and y2. So which formula is best suited? Yes, it is the midpoint. Q is the midpoint. So let's write the midpoint formula. Right? So what is x here? X is 1, x1 is 4, x2 we have to find out. So 2 equal to 4 plus x2. So what is x2? Yes, it's minus 2, friends. See, just in a matter of few seconds we got the answer. Now let's also find out the y coordinate. This is the midpoint formula for the y coordinate. So what is y? Yes, minus 3, y1 is minus 1 plus y2 by 2. So minus 6 equal to minus 1 plus y2. So y2 is minus 5. So what are the coordinates of point R? Point R coordinates are going to be, yes, x2, y2, which is minus 2, minus 5. Friends, this is the answer. So here are a few questions for practice based on each of the formula, distance, section and midpoint formula. Please do try out these questions and let me know your answers in the comment section below. So friends, if you found this video useful, please do like and share. Consider subscribing to Enjoy Math and please leave your suggestions and your feedback in the comment section below. So till we meet again, take care.